Hello, programming languages students. Welcome back for another Prolog video. Today we're going to talk about, or I guess in this video I should say, we're going to talk about how to use backtracking, or really the cut, the exclamation point operator, to prevent backtracking in some really useful ways. And for that demo, we're going to use this factorial predicate. And so for factorial, if you'll remember, kind of coincidentally enough, in math, factorial is the exclamation point. So 4 exclamation point is 4 factorial. And we're going to be dealing with the Prolog version of exclamation point, which is our cut that prevents backtracking. So a little coincidence there. But back to the task at hand. Factorial is a number times basically that number minus 1 until we reach the value 1. Um, and so 4 factorial is 24, assuming my math is not terrible. And the way you get 4 factorial is 4 times 3 times 2 times 1. 5 factorial would be 5 times 4 times 3 times 2 times 1. And so on. And so the way our factorial predicate works, we have our base case, 1, 1. So the easiest factorial to calculate is 1, and that's because its factorial is 1. 1 times 1 is 1. So that's our base case. And then our recursive predicate takes an n, which is the number we're looking for. Let's say we were looking at 4 factorial. This would be 4. And then n factorial, this is what we would get out. And so it would be, this should end up being 24. And the way we do this is a recursive loop, recursive call, where we say that m is n minus 1. So if n is 4, that means that m will be 3. And so we call a factorial with 3, and we don't know, well, I guess this would be 3 factorial. And we loop back in, n would then be 3, which means m would be 2. We'd look for 2 and 2 factorial, and ultimately we get to 1 and 1 factorial. And so with a 1, 1, we work our way back up, calculating our factorials as we go back up the loop, back up the cycle of recursive calls here. And we multiply each time whatever the previous factorial was by the current number. So 1 times 2, 2 times 3 is 6, and 6 times 4 is 24, and that would end up giving us our n factorial here. So that's how the function should work. Let's run a couple examples here. Uh-oh. Well, we found 1. 1 factorial should be 1. But then we went infinite. So why did we go infinite? Well, there's not a cutoff. So once we find 1 and 1, we're going to check 0 and then -1 and then -2 because this recursive call doesn't have a limit, right? We could put a limit in here. We could add something like n is greater than or equal to 1. But this still runs, right? We still find x equals 1, and then we keep hunting for another answer and then get cut off because we cut ourselves off here. Without this limit of n greater than or equal to 1, we'd go forever, as we saw the first time. But neither of these behaviors are really what we want. Really what we'd like is to be able to find a factorial and just be done and not have to keep searching. And that's the idea of cutting and backtracking, is to stop. Even if you get rid of this infinite loop with a conditional, you're still going to keep searching until you run out of time, or until you run out of options that work. And so we want to cut it off. And so one really common way that people use this cut operator, this exclamation point in Prolog, is by adding it to their base case. Now, this does not always work. This is not always the solution, but it is a relatively common solution to cut ourselves off, to stop backtracking once we have found one base case. And the nice part is, if we add this in, we don't have to add the logic for n is greater than or equal to 1, or m is greater than or equal to 1, or whatever. And instead, we just get our answer and then stop. Because the first time we go back and find our base case, it stops. There's no more backtracking. There's no more testing. All right, well, we found a true case for 1, 1. What about 0, 0, or -1, -1, or I guess 0, or -1, or -2, or -3, or -4, or -5. And so we cut ourselves off before going infinite because we stopped this backtracking. So this is a really common way of using backtracking, and it gives us the benefit of getting only one correct answer and then stopping. So if we have another function that depends on the result of this factorial call, then we aren't going to run into problems of finding one solution, then having to pause and hunt for more solutions. Instead, we'll just get the one solution and be done. And so that's why backtracking is so important, and cutting off backtracking is so important at times. So generally, when you're first starting with this, you can play around with it a little bit, but following decision trees, especially simple decision trees, should show you where you need to cut as you go along. And you can always try it in a couple places. Again, if you're new and you're testing things out, feel free to plop it in a couple places and see the effect. Just know that if you put it in the wrong place, it may give you completely incorrect results. So I would try to find correct results without the backtracking cutting, but then dive back in and see where can I cut this off so that once I get a correct result, we're done. Hopefully that's helpful. At this point, you should be ready for the assignments that I've given out. Um, and be sure that once you've found a good solution, that you find a good way to backtrack so that your solution always prints out one answer and does not search again for another answer, even if it comes back as false. That extra search can be a bit of a problem at times when you start doing a lot of Prolog um, backtracking and Prolog predicate building. And so having good programming practice of just putting in good backtracking cuts can be very, very helpful, and it's a good habit to get in early. So I'm going to ask that you guys start that early in your Prolog programming here. So if, again, as always, if you have any questions, let me know. See you guys later.